Welcome to LinuxConfig.org. In this tutorial, we'll explore ZFS compression and demonstrate how it can save significant disk space without sacrificing performance. We'll compare different compression algorithms including LZ4, GZIP-9, and ZSTD, showing both their space savings and speed characteristics. First, let's verify our ZFS installation and pool status. We'll run zpool -- version to check our ZFS version. Next, Zpool status shows our pool named ZFS pool is online with no errors. Finally, ZFS list displays our datasets. We can see the ZFS pool / LinuxConfig dataset using 24K with over 9 GB available. Now let's check the compression setting on our dataset. Running ZFS get compression ZFS pool / LinuxConfig shows compression is currently set to off. We'll also check the current space usage. Notice the compress ratio is 1.00x, meaning no compression is active. This is our baseline. Next, we'll download a sample CSV file to /temp for our tests. The file is about 312 megabytes in size. This will be our test data for comparing compression performance. Let's change to our ZFS pool / LinuxConfig directory and copy the sample file. We'll use cp to copy the file from /temp. Running ls-lh shows our file is now in the dataset. Now let's check how much space this file actually uses without compression. The used property shows 311 megabytes, and logical used is also 311 megabytes. The compress ratio remains at 1.00x. Running ZFS list confirms the dataset is using the full 311 megabytes. The file is stored completely uncompressed. Let's remove this file and test with compression enabled. Now let's enable compression. We'll run sudo ZFS set compression = on. When we set compression to on, ZFS uses LZ4 by default, which is the fastest compression algorithm. Checking the compression property confirms it's now set to on. The dataset is currently empty, showing only 24K used. Notice something important here. Even though compression is now enabled, the compress ratio still shows a 1.00x. That's because the dataset is empty. Compression settings only affect new data written after enabling. There's no data to compress yet, so the ratio remains at 1.00x. Now let's copy the same file again, but this time with compression enabled. After the copy, ls-lh still shows the file as 312 megabytes to applications. But here's the magic. Let's check the actual disk usage. The used property shows only 187 megabytes, while logical USD shows 311 megabytes. The compress ratio is now 1.66x. This means ZFS saved 124 megabytes of disk space automatically. Running ZFS list and df-h confirms we're only using 187 megabytes on disk. The file appears normal to all applications, but takes up much less space. Let's remove the test file and prepare for our compression speed tests. Now let's compare compression speeds with different algorithms. First, we'll set compression to off as our baseline. Before the test, we'll run sync to flush any cached data, then clear the system cache to ensure fair results.
Now we'll copy the same file 10 times using a loop and measure how long it takes.
Without compression, copying 10 files took almost 10 seconds. Running ls shows all 10 copies, and ZFS list shows the dataset is using just over 3 gigabytes. Let's clean up and test with compression enabled. Now let's test with LZ4 compression. But we'll set compression to LZ4, which is ZFS's default and fastest algorithm. Again, we'll sync and clear the cache for a fair comparison, running the same test with 10 file copies. While the files are being copied, ZFS is compressing each one on the fly using the LZ4 algorithm. This compression happens transparently in the background without any application changes needed. Interesting result, LZ4 completed in just over 8 seconds, which is actually faster than no compression. This happens because LZ4 is so efficient that the CPU compression overhead is minimal, while the reduced disk I/O from writing less data makes the overall operation faster. Checking the compress ratio shows 1.66x compression. ZFS list shows we're using only 1.82 gigabytes instead of over 3 gigabytes. That's significant space savings with better performance. Let's clean up and test the next algorithm. Now let's test GZIP-9, which offers maximum compression. We'll set compression to GZIP-9 and clear the cache again, running the same 10 file copy test. I've deliberately cut out the waiting time in this video, but the actual result was 39 seconds. That's significantly slower than both LZ4 and no compression, because GZIP-9 uses much more CPU power to achieve better compression. However, look at the compress ratio, 2.59x. That's much better compression than LZ4's, 1.66x. ZFS list shows we're using only little over 1 gigabyte compared to over 3 gigabytes without compression. So GZIP-9 gives excellent space savings, but at the cost of slower write performance. Let's test one more algorithm. Finally, let's test ZSTD, which is a modern compression algorithm. We'll set compression to ZSTD and clear the cache one more time, running the same test again. Again, I've cut the waiting time to save you from watching the entire process, but the actual time was 33 seconds. That's faster than GZIP-9, but slower than LZ4. The compress ratio shows 2.58x, which is nearly identical to GZIP-9's compression. ZFS list shows we're using about 1.18 gigabytes. So ZSTD offers excellent compression similar to GZIP-9, but with better performance, making it a good middle ground choice. Let's review what we learned today. Looking at our comparison table, we tested 4 compression scenarios with the same data set. LZ4 compression was the fastest at 8 seconds, even beating no compression at 10 seconds, while providing 1.666 compression ratio. GZIP-9 achieved the best compression at 2.5 forest 9x and used only 1.17 gigabytes, but took 39 seconds. ZSTD offered an excellent balance with nearly identical compression to GZIP-9 at 2.58x, but completed 6 seconds faster at 33 seconds. For most use cases, LZ4 is the clear winner. It's faster than no compression and saves 40% of your disk space with minimal CPU overhead. If you need maximum space savings and speed isn't critical, use GZIP-9. For new deployments wanting strong compression with better performance, ZSTD is an excellent modern choice. The key takeaway: always enable compression on your ZFS datasets, because even the fastest algorithm improves both performance and space efficiency. Subscribe for more Linux tutorials, and thanks for watching.